Um, any questions regarding previous class? Any questions from previous class? Anybody? Uh, okay. You haven't gone through. Understood. No assignments from yesterday. Yeah, I think that you will see assignment today. Was added today, I think. So you should find some. Okay. Just to give you a brief idea, we covered introduction to Node.js and what Node.js does for us. It executes JavaScript basically. Then we have global variables. We looked at the global variables available in Node.js, and then we looked at uh, three types of modules that Node.js supports. So there are built-in core modules, then there are user-defined modules, and then there are third-party modules. Okay. In third-party modules, we looked at Faker and Axios. Okay. For core modules, we discussed crypto. We discussed file system module, operating system module, things like that. And then for user-defined modules, we created a very simple Fibonacci module, which exports two functions. Okay. Any questions right now? How is it suggesting last edit time? This is an extension. You can download an extension. I think the extension is git lens or something. Okay. So whenever you commit, this is the commit message. And I committed 21 hours ago. Cool. So if there are no other questions, then we can come to today's session. In today's session, we are going to talk about HTTP. So you already know, you have some idea what HTTP is. Basically, we work with HTTP calls all the time. So we have worked with localhost when hosting React application in our local environment. So, but in this lecture, we will go a little bit into the depth of how HTTP works and what is happening under the hood. Okay. So in this lecture, we are going to cover a few things. So what is first, this question we will answer, but what happens, we'll start with what happens when we send a request from browser. Okay. Then what is the role of HTTP in all this? What does HTTP do? And then working of HTTP, right? How HTTP works. After that, we will take a look at different HTTP requests and response modes. Okay. This is what we are going to cover today. Okay, so cool. Then let's start with a drawing. So I have created this drawing, and I'm going to walk you through this entire drawing, uh, segment by segment. So uh, I draw this earlier so that we don't waste too much time in the lecture while drawing this. Okay. So let's begin with the first question, which is what happens when we send a request from a browser. Okay. So let's just say I'm sending a request. Uh, I'm just sending a request to this page. Okay, this one, or let's say this page. Mm, say this page, right? So if I open network tab, you can see all the network requests that are made from here, right? This is these are all the network requests. So you can see there are around 71 requests. All of these are going through. If you look at the if you go to the headers tab, you will see everything starts with HTTPS, right? So the first request that we made, it is this one. Now it downloaded some HTML, right? With that, it downloaded some CSS, then it downloaded some JavaScript, then it downloaded some images, right? And then it made some XHR request, fetch requests. Okay, this is clear, right? Everybody knows what it is doing. So all of these requests are made using HTTPS. Okay, so these are all just a chain of HTTP requests, and then we are getting some response based on the type of request. We can get different type of response. We can get HTML data, we can get CSS file, we can get JavaScript file, we can get an image, we can get font, we can get JSON data, right? So all these things depend on the type of request that we make. Okay, so does anybody know where does the request go initially when we make a request? For all these requests, whenever we make a request, this is what happens. It first goes to DNS, right? So what is DNS? uh, DNS is called domain name server. So domain name server, it doesn't directly go to server because the browser doesn't have any idea where is the server. So browser has no idea where the server is. So it goes to DNS, right? So DNS is sort of like a middleware which will see the URL and see that hey, this is github.com domain. So github.com domain, the request should go to this IP address where the server of this uh, where the server of github.com is. So it will redirect the request to, it will convert the request from a URL to an IP address. Okay. So you can also see this when I make a request in the headers, you will see something like remote address. Okay. So similarly, if I make a request to, let's say, Xcali draw, then it will have some other IP address. For example, uh, github.com request goes to this, right? Uh, github.com request goes to this, and Xcali draw request goes to this IP address. So every domain has some IP address, and uh, who manages this IP address? This IP address, whoever owns the domain. So let's say if I am the owner of some domain, for example, example.com. If I am the owner of example.com, then uh, I would have bought that domain from somewhere, right? So let's say GoDaddy or Namecheap or uh, AWS or Google, my whatever, right? Wherever I buy these domains from, I can uh, I can enter that an IP address that hey, what if anybody makes a request to my domain, it should go to this IP address because that's where the IP address is. Just 1 second. Okay. So depending on what type of domain, whatever domain I buy, if I am the owner of the domain, I will be able to add the IP address. I will be able to map the IP address. So if any user makes a request to my domain, it will go to that server. And that is a job of DNS. Okay. Is this clear? Any questions so far? No? Okay. So once it will convert there is a question, it will convert the request to respective IP address. It will redirect the request to to that IP address. Whatever mapping we have defined in our domain as an owner, whatever mapping I define, the request will go to that IP address. Okay. It will just be redirected. Right. Why is it done? What is the purpose of having DNS layer? It is so that all users like you and me will not be able to remember the IP addresses, right? We will be able to remember these names, alphabetical names easily. So github.com, everybody remembers. But if you were to, if I give you a task to remember this IP address, every time you make a request to this, you will not be able to remember this, right? So this is not going to work. Okay. So see, if I make a request to this IP address, it directly goes to github.com. Yes, mapping is one-to-one. Every time we make a request to this domain, every time it goes to this IP address, whatever IP address that owner of github.com has defined. Okay. It cannot have multiple IP addresses. So the IP address we get is of the DNS and not the server. Do you mean this IP address? This is not of DNS. This is of the server itself. Okay. Yeah. Cool. So once the request goes to the server will identify whether this is a valid request or not. Okay. So let's say we are making HTTP request and server understands HTTP, then it will respond. Otherwise, if we make another type of request, not HTTP request, let's say, if we make any other type of request, but server only understands HTTP, so it will not be able to give valid response. Who is creating these IP addresses? This is a question somebody has asked. So whenever this question, whenever we deploy our code, it is running on some machine, right? And that machine is connected to internet. So every internet connection has an IP address. Okay. Every internet connection is having an IP address. So anybody from outside, from anywhere from the internet, can communicate with that IP address. Okay. So it is nothing but a computer which is connected to internet. And because it is connected to internet, it is accessible with some IP address. Okay. Every machine has an IP address which is connected to an internet. Clear? Okay. So depending on the type of request, the server will process that request and send the response. Similarly, there can be another client somewhere else. Okay, somewhere else in the world, and if they send a request, that request will go to DNS, and again DNS will redirect that request to some IP address based on the domain, and then it will reach the server. Okay. Server is nothing but a program which is listening for these requests, and it will process that request and send the response. Clear? And depending on the type of request you have seen, depending on the type of request, we will get different response. Okay. Okay. So this is the answer to this question. What happens when we send a request to the browser? When we send a request from the browser, it goes to DNS. Then DNS redirects the request to some IP address. IP address is where the server is, our server is running, our program is running, which is listening for these requests. And depending on the type of the request, it will process and send the response back to the client. Okay. Uh, okay. These questions, right? Like, what is the difference between HTTP and HTTPS? Don't worry about these questions right now. First, let us just understand what HTTP is. Okay. I will cover all of the topics that are required for you to know. After that, if you feel there is something that is missing, you ask these questions. Right now, just focus on what is being taught. Okay. Right. Answer why browser throws warning when we connect to HTTP connection. Yeah, that we will cover later. Okay. Okay. Now the next question is, what exactly is HTTP? So right now we are seeing HTTPS, but don't worry about HTTP and HTTPS right now. They just imagine that they are same thing. For now, imagine that they are same thing. There is a very minor difference, and I will tell that difference later on. Okay. Right now, whenever I say HTTP and HTTPS, just imagine that they're the same thing. Okay. So what is HTTP? HTTP is a protocol. So what is the meaning of protocol? Protocol means uh, we define, sorry, we define a set of rules or set of steps. And these set of rules or set of steps, they are followed by each HTTP request, right? By each request, these rules are followed. So uh, now, what are these rules and how are they followed? And we will talk about all of that when we talk about working of HTTP. Just imagine that HTTP is a protocol. So whenever we say it is a protocol, it means there are some set of rules and they are supposed to be followed by each request. Now, HTTP is not the only protocol. There are other protocols also. Okay, other protocols like uh, POP, okay, uh, gRPC, IMAP, FTP, yes, and there are so many. So some examples are like this: SMTP, SSH, IMAP, POP, TCP, right? All of these are just acronyms. They have uh, some they have some full form as well. So each full form is just a name, and they are doing same things. The only difference between all these protocols is that they are built for different functions. They have different roles. Okay. So each protocol does a different thing. Okay. So I'm giving you definition or the full form for uh, few of these protocols. So hyper text transfer protocol, TCP, transmission, I think it is transmission control protocol. There is SMTP, simple mail transfer protocol. SSH is also one of the protocols. So it also, I think, secure shell protocol. Okay. So these are all just protocols, and what is a protocol? Protocol is nothing but a set of rules. So each protocol has different rules, but these rules are followed by every request. So if a request is HTTP request, it will follow all the rules defined by HTTP protocol. If a request is TCP request, it will follow all the rules defined by TCP protocol. Similarly, SMTP protocol, all the requests which are as all as SMTP request will follow SMTP's rules. Now these rules are defined in such a way to fulfill the purpose of these protocols. So HTTP is network request, so that when we make a request from browser, we send a request, we get the response back. Okay, we send a request, we directly get the response back. Okay, similarly, TCP is also similar to HTTP. SMTP is used for mail transfer. SSH is used for connecting to a remote terminal from from one terminal so to another terminal to control one terminal from another terminal. Okay, so all of these protocols do different things, and there are nothing just but protocols, set of rules. Okay, and HTTP, what does HTTP do? It allows us to send requests from browser, and we immediately get the response. Okay, if the request does not fall under the protocol of HTTP, then it should fall under some other protocol, right? Each request is some type of follows some type of protocol. So if, for example, if we send a request to some server, right? And let's say if we send SMTP type of request, but the server is not configured in such a way to understand SMTP type of request, then it will not be able to fulfill the response. That's it. Okay, the request will fail. Right at this point, the request will fail. Okay, it will not, server will not even accept that request. Okay, sometimes whenever if there is an IP address and we try to send HTTP request and server is not configured to understand HTTP request, you will see the request will fail. Okay, and I will show you in this series only. When we do deployment, I will show you what happens when we make a request, and before we configure the server, if we make a request, what happens. Okay, I will show you that. Cool. Now everybody understand what is HTTP? HTTP is nothing but a protocol. So it allows us to send request from browser, and we immediately get the response if it is a valid request. Clear? Is this clear? Okay. So each request asks for some type of resource. So this resource could be HTML, HTML data. It could be CSS. It could be JavaScript. It could be image. It could be MP3 data, whatever, right? It could be some video. It could be JSON response, whatever. So these are all just resources. So we ask for resource and we get the resource immediately. Okay, depending on the type of request we make. Now, how does this work? How does this all of this? What are the set of rules? We will look from the surface. What are these rules, and how does HTTP request works under the hood? Okay, how does this HTTP protocol works under the hood? Okay, so this is the diagram, and this is for HTTP and TCP protocol. They are very similar, and this diagram is common for both of these, right? Don't just assume that since we are understanding HTTP, we're just talking about HTTP only. This diagram is common for both HTTP, TCP. and HTTPS type of request. There is a question. Resource means the format of the output. No, no. Resource means something that we are requesting for. So if we are requesting for HTML page, then HTML page is the resource. This is type of resource. Okay. HTML is type of resource, but the data we get is the resource. The actual resource is the data we get. Okay. The response we get is the resource. If we are asking for the correct resource, we will get the correct data, right? So this three-way handshake that we are going to talk about is common for HTTP, TCP, HTTPS, all type of protocols. Okay. So I like to explain this with a story, and that is an analogy, and it will make more sense if we see this from that analogy's point of view. Now, suppose you are a customer and you go to a shop, right? So you are the customer and uh, shop owner. You will go and talk to the shop owner. Now, this is not your neighborhood shop. Let's just say you are in a completely different place and you don't know what language does the shopkeeper speak. Okay. Are you able to follow me? You are a customer. You go to a shop. You don't know the language the shopkeeper speaks. Right. So, how will you initiate the conversation? You will try to greet the shopkeeper in the language that you know. Okay. If you know Hindi, then you will try to say namaste, whatever, right? If you know English, you will try to say hi, hello, okay, something like that. So, whatever language you know, you will try to greet the shopkeeper, hoping that the shopkeeper will respond in the same language. Correct? Are you able to follow this analogy? Uh, Ramanpirit, is this fine to you? Are you able to follow? Is there any doubt? Yeah, yeah, he will obviously respond in his language. I'm saying you hope that he will respond, or he should he you're just hoping that he should speak the same language that you do, right? So you will greet in your own language. There is no way to know what language does the shopkeeper know until you greet them in your language, right? So now there could be two possibilities. Either the shopkeeper will understand your language and greet back, or shopkeeper will, shake their head saying, "Hey, I don't know what you're saying." Right? But it is, common sense that they will understand that they are just, probably trying to ask for something. But don't worry about that. For this analogy, just assume that if shopkeeper doesn't speak the same language, they will shake their head, right? And they will not accept your greeting, right? Okay. This is the same thing what happens when we send a request from our browser to the server. This is the same thing that happens. And where you are the client, right? Browser is the client. Just as you are the customer, browser is the client, and it is the responsibility of the browser to initiate the conversation, to initiate the connection. Okay. Because browser is the one who is requesting for some resource, right? It will not be the server who will go to the client. Similarly, it will not be the shopkeeper who will go to the customer, right? Customer has to initiate the conversation. Similarly, client has to initiate the communication or the connection with the server. Are you able to follow me till this point? Okay. Now that is the first step. Client initiates the connection. Okay. And client will initiate in the HTTP protocol only, because browser only speaks HTTP language, or browser only follows HTTP protocol. So the first uh, the first interaction that they do is called sync interaction, and you can write SYN in short. So client will initiate the connection with a sync call. Okay. Then server will can respond in two possible there can be two possible outcomes. Either the server will understand the HTTP connection, either it can accept the connection or it can decline the connection, saying that I don't speak HTTP. Okay, I don't know which protocol you are following, but I don't follow this. Okay, clear? Yeah. So if server understands the HTTP protocol, then it is a job of the server to respond back to the client saying, hey, I understand your request. I also follow the same protocol as you do. So it will acknowledge the request, and it will send a request which is called sync plus acknowledge. Okay. So that means they will client will also know that server understands HTTP protocol, right? After that, it will acknowledge this. Client will acknowledge that, hey, I have received your acknowledgement. Okay, that is the third step. And with this, client can start sending the request. Once once these three steps are followed, after that the connection is completely set up. After that, client can send a request. Okay. Yes, every time the request will go through DNS. This is not the purpose of DNS though. Okay. The purpose of DNS is just to convert the domain to an IP address. All of these things are happening at this point when the request is going to the server. It is happening at the server layer. Okay. This is not happening for DNS. For each request, this will happen. For each request, uh, these are all 72 requests in total. So for each 72 requests, the request will go to server, and first they have to follow these three steps. Okay. Is this clear? Any questions here? No questions? I'm pausing for your questions if you have any questions. Okay. Now, depending on the request, server will understand the request. For example, if I am just asking for an HTML page, server will check that this request is for an HTML page. So it will process what should be the response as an HTML page, what exact response it should send. So then it will start sending the response. This will happen for each request. Okay. No matter how many requests we make, I have made 72 requests here. This will happen for all the requests. Okay. And there is a question, how client acknowledge before getting response. Client will acknowledge here. First of all, client will initiate the conversation with a sync call. Server will send acknowledgement and also send a sync call. Then client will send acknowledgement. Then it will send the request. Okay. Then the server will start processing this request. SYN means sync. Yes. Synchronous. Okay. Why not client sends the actual request on the first time itself? So this question can be answered with the analogy. If you are in a completely different area, right, completely different state, will you just start giving order to to the shopkeeper in your language? First you have to actually uh, communicate with the shopkeeper, that you have to make sure that the shopkeeper will understand you, right? You will not just go ahead and, if you go to, let's say, Odisha or Tamil Nadu, you will not just start speaking Hindi, right? Because there is a good chance that they will not be able to understand you. Okay. Does that answer your question, Surya Prakash? Right. Okay. So this is called three-way handshake. Why? There can be multiple back and forth communication here for the same request, but we call it a handshake because with these three uh, back and forth calls, they set up the connection. After that, there are multiple back and forth communication going on, but these first three calls are just for setting up the connection. Okay, that's why we call it handshake. That is not the complete request, that is just the handshake or the setting up of connection. Okay, so it is three-way handshake, right? If somebody asks you what is three-way handshake, you will be able to explain, right, with this? Okay, any questions here? No. Okay, if there are no questions, I'm proceeding then, right? So just know that you now know three-way handshake. Okay, now suppose the next segment, now we have answered this question, working of HTTP request, and this is like following the under the hood. What are these rules? Rules are three-way handshake, and there are many more rules. It's not like this is the only rule in HTTP protocol or TCP protocol. There are other rules also, but this is one thing that is something you should know. Okay, this will happen after DNS layer. Yes, yes, this happens when the request hits the server. Okay, once the IP address is resolved from the domain and the request goes to the correct machine on the internet, right? That is when this happens. Okay, now we have covered all these topics, working of HTTP. Now, what if I am asking for, let's say, a file which is 4 MB, a response which is 4 MB in size? Okay, so these type of request, in fact, any request will flow, and server in HTTP protocol, you do not get the response in just one attempt. Like, this may be misleading, saying that there is only uh, one only in one attempt the response is received by client from the server. In fact, what happens, there is a back and forth communication happening for the same request. Okay, for the same request, let me just make it clear to you very explicitly. Let's say I am asking welcome.html page. I am asking for http example.com/welcome.html. Okay, I'm asking for only one resource right now. So if this resource is, let's say, 4 MB in size, okay, if this is 4 MB in size, response will not server will not send all 4 MB data in just one attempt. What will happen? It will say, hey, I have uh, I have this response, I am breaking this response into multiple parts called chunks. Okay, chunks or packets. Okay, I will break the response into multiple chunks. You have to keep coming back to me to get all these chunks. Okay, so server will send the first chunk. Client will say, okay, I have received the chunk. Send me the next chunk. Okay, then it will send another chunk. Okay, so for with each chunk, server will say, this is a chunk. I have more. You have to come back to get more chunks. Okay, and with each call, client will go back and request for another chunk. So this keeps on happening back and forth. This will happen until we reach the last packet or the last chunk. Okay, so this will keep on going after some time. Okay, after some time, server will say, okay, this is the last one. This is the last chunk or the last packet, right? So like this. Okay. So after the last chunk is delivered, the communication will be complete and the response will be sent to the client and this request will be over. Okay. Is this why we do data.json? No, 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 no. That's not exactly that. Why server will not be able to give in one go? There are multiple reasons. So it's we don't see it happening, but for one request there are a lot of uncertainties. Okay, uh, every time the network is not very stable. Okay, so sometimes what happens, uh, client sometimes misses the chunks. Whenever server responds, client will miss that chunk. Okay, so to handle these scenarios where there is a miss happening and something is not captured by the client, we have they have set up uh, this type of setup. They have made this type of setup so that there can be very minimal loss of data. Okay, very minimal loss of chunks. If we were to do this in one attempt, the request will never succeed. Okay, all of this process will be taken care by the browser itself. You do not code this. We as a user, when we make a request from browser, we do not code this. Server does not code this. Okay, all of this is implemented in the operating system layer itself. Okay, we only use what is already implemented in the operating system. Okay, just 1 minute. Okay, sorry, I just received a call. Now, does this make sense? All of this, why we break the response in multiple chunks and how client is coming back to ask for more until we respond with the last chunk or packet. Okay. All of this is configured in the HTTP protocol, and this is how the response is sent. We are telling you this because somebody could ask you this in interview. You don't have to code this, you don't have to worry about this, but you somehow have to know this. Okay. Sometimes they ask you these things in interview. These are theoretical topics. You don't have to worry about coding all of this, but this is how under the hood HTTP is working. So if somebody asks you in an interview how HTTP is working under the hood, you could explain by with this all of this theoretical topics. Okay. Understand? Cool. Any questions so far? Okay. Now this was all very theoretical. Now suppose uh, uh, we will also make a very basic HTTP server in Node.js. But before we do that, and we will code that server using core modules only. Okay. So, but before we do that, I will just try to summarize what you already know. And you already know different types of HTTP requests, right? Okay. So, does anybody know how many different types of HTTP requests are? These are all these get, post, put, patch, delete. You have heard of these, right? Okay. So, uh, let's go over each of these and understand what does each type of HTTP request is used for. So first of all, get type of HTTP request is used to get some data. Okay. It does not modify anything on the server. It just fetches the data. Okay. So suppose you're asking for user details. Okay. So you make a request to the server. Server will give you the user details. It will not modify anything about the user details. Okay. Maybe it can modify something like how many times the user has requested or something like that. Okay. But that doesn't change anything in the user data. Okay. Then there is another type of request is post request, where uh, we make a request to the server if we are creating something or adding some resource to the on the server. So for example, when you are making a Facebook post, right? So you are adding something which was not existing earlier, which did not exist earlier, but you're adding something. Okay. So like a Facebook post or an Instagram post or YouTube video or a WhatsApp message that did not exist earlier, you are making a post request at that point so that something new can be added. Okay. Some new data can be added. It can be anything. Some new image or text or something like, okay, something like a video, voice note, could be anything. Okay. So that is what post request is used for. Clear? Then we have put request. So put request is used where uh, if the data exists already, it will be updated. If the data does not exist, then it will be added. Okay. So it's like insert or update. Okay. So for example, when um, it could be in real life, if you take an example, it could be uh, when you try to log in with your phone number. So what that application will do, what server will do in this case, if the user already exists with that phone number, then it will send an OTP to that number. Okay. the data already exists in the database. But if that data does not exist in the database, it will add a record of that phone number in the database and then send the OTP. Okay, clear? Are you able to follow me? Okay, so this is insert, this is read. Put request is used for if the data already exists, then it will update. Okay, otherwise it will insert if it is a new data. Okay, for existing data it will act as an update. For new data it will act as insert. Okay, similarly patch is used for updating uh, update of existing data or existing resource. So for example, let's say if your profile picture already exists, then it will replace the existing profile picture with the new profile picture. Okay. Delete will completely remove the resource. Okay. And there are other types of HTTP methods. We call these HTTP verbs also. If somebody asks you what are HTTP verbs, then they are just nothing but same as HTTP methods. Okay. Now option method is used to identify if server supports a method for a request for an endpoint. Okay. So for example, if we are checking that this is the endpoint user slash user slash 34. Let's add HTTP here, example.com. Okay, if we ask the server, this is the endpoint. What are different HTTP methods supported for this endpoint? So server could respond with, we support get, patch, and delete. Okay. So then we can make a request to get. Otherwise, if let's say we are making a get request and the server does not support get request for this endpoint, then that request will not be successful. Okay. Is this clear? Right. So these are all the HTTP methods. And right now we have talked about what happens when we send a request from browser to the server. Then we have talked about what is HTTP and what are different types of protocols. What is a protocol? What does HTTP do for us? And how does HTTP work under the hood? Now we have also talked about HTTP methods. Okay. Is this clear? Now, if this is clear, then depending on whatever request we make, so for each request, we can say what is the endpoint, what is the method, request method. Okay. So let's say endpoint is this example.com slash welcome.html. This is one endpoint, and this is another endpoint. And all of we also say what is the method for each request. So there is get method. So for each request, I am going to write each request like this. Okay. If I am making a get request, then this. I can also replace it. I can also replace the domain name or the base URL. I can also remove that. Or if we are, let's say, adding a post request to, let's say, slash register, that will be this. That will be this request. Okay. If I write post slash register, that means I am making a request to http colon slash slash example.com slash register. this will be a post request. एक सेकेंड. So this is how we are going to identify or represent each request. Okay, if I make, let's say, patch request to slash profile, that means I'm making a request to http colon slash slash example.com slash profile, and this is going to be a patch request. And by the http method, you can tell that I am going to update something in my profile. Okay, clear? I will share the diagrams, don't worry about the diagrams. I will share everything in the notes. So this is how we identify. Now this is all about request, and we can also get different types of response. Okay, yesterday's lecture has not been updated. Okay, I'm just saving the video. This was created today only, so that's why I did not upload. Don't worry. In the on the GitHub, this is updated. We'll talk about this later. Okay. Coming back to the lecture, we have talked about how to represent each request. Now I'm talking about different types of HTTP responses we can get. Right. So you may have seen 200, and we talk about status codes first. So every response, you can see every response here you can see status code. So for each response, you can see there is a property called status code, and these status code are nothing but they will tell us how what kind of response we are getting from the server. Okay, so there is 2xx, there is 3xx, there is 4xx, there is 5xx. So these xx stands for any number from 0 to 299. Okay. And 3xx stands for 300 to 399. Similarly for this and this. Okay. Is this clear? These are response codes, and each of these falls under a category. Sorry, yeah. Each of these we can define as 2xx or 3xx or 4xx or 5xx. Now 2xx will always be success type of response. Okay, so 200 means success, 200 means okay, everything is okay, we got what we were hoping for. Okay, 201 is, I think, when we are creating something. Let's say we are making a request, post type of request, and we have successfully inserted the data. Okay. Similarly, 202 means something. We don't need to remember all of this. We just need to understand this. That's why I'm not telling you. I don't even remember what 202 stands for, but I know that it is one of the success type of a status code. Okay. Similarly, 300, 300, this 3xx type of category is used for redirection logic. Okay. 500 type of 4xx type of response code means something is wrong with the request. Okay, so it could be let's say bad request, that means server uh, could be bad input. 401 could be we are not authenticated or authorized. And the most famous one, 404, That means server does not have what you're looking for. Okay. Okay. Redirection logic. That means, let's say if we make a request to some IP address, right? Let's say if we make a request to http:/example.com/welcome.html. The server will check, okay, user is asking for welcome.html, but server will say, hey, this page is moved to a new location, and that location is instead of welcome.html, it is home.html. Okay, so this is we server redirects the user to some other URL or some other location. Okay, in these cases we use 3xx, right? Server will not directly send the response. Server will say, instead of you're making a request to welcome.html, server will say something like 300 or 301, and it will send this data in the response, saying rather than coming to this URL, go to this URL. And the browser will automatically understand that. Browser will automatically understand uh, that user is should be redirected from this to this. Okay, does this make sense? Now, coming to 500 type of status code, it could 500 means server internal error. Server understood the request. There was nothing wrong with the request, but server crashed while trying to process this request. Okay, server something went wrong while processing the request. Okay, this is all about the different types of responses server has to send. And why we are looking at all this? Because we are going to build the servers, and it will be our responsibility to send the response with the correct status code. While we are sending the response, it will be our responsibility to attach the correct status code with the response. Okay, so that client can understand what type of response they are getting. Clear? So if a server makes a request to, if a client makes a request to, this URL, and there could be some body, request body. Okay, request body could look like I am updating my, let's say, address, and this is 221 the Baker Street, Sherlock Holmes fans. Okay, so if I am updating my address to this, then server could say 200. That means everything went wrong. Sorry, everything was, it is a successful type of response. Your data has been updated. Okay, or server could say 400. 400. That means something is wrong with the request. Okay, could be some field missing in this request body, could be something wrong with the URL. Okay, it could be anything. So 400, we could get this type of response. Server could send us 500 type of response, saying that this should be success. That server was trying to process, but something went wrong. Okay, something went wrong. So for each type of request, we could get different types of responses, right? Depending on how we make that request. Clear? Is this request, is this clear? If this is clear, then we have understood everything above. Okay, cool. Right. All of these are very, very important concepts if you are interested in building uh, backend systems. If you're interested in working on backend, then these are very important topics, and you're supposed to know all of this. Okay, so that's why we are bothering so much to teach you all of this. Otherwise, you could learn this from anywhere. Fine. Coming to the last theoretical topic. After that, we will start completely just jump into building the server in Node.js. This is, I promise, the last theoretical topic that you have to know. And it's actually very interesting. Okay. So right now we have understood how HTTP works and how what are these conventions, get request, post request, all of these are conventions with status codes and what happens under the hood. But coming to the gist of it, if you are making a server and if you're running that server on a machine, then it has to be connected to internet to accept traffic from outside, right? Okay, is this clear? Yesterday, I showed you a little diagram showing that this is an operating system, right? This is an operating system. In this, we have multiple processes running. So we have Chrome. In this, I have Xkelly, Draw. Okay. Then I showed you that my VS Code is also running. So that is another process. Then I showed you Zoom is running. So all of these are processes, right? Then, for example, it could be file browser, file explorer. All of these are processes, correct? Now, uh, server is also going to be one of the processes for us. Node.js server. It is also going to be executed as an operating system process. Okay. Now, whenever we get a request from outside world, right? Let's say this is the IP address. For example, if this is the IP address and this is mapped to, for example, http colon slash slash example.com. Okay. All the requests coming to this, there is some DNS sitting in between. So any request coming to example.com, DNS will send to our machine. Okay. This IP address. So we get this. This sends us to this. Now, how does our machine or operating system know which of these processes is actually the server, right? This is a question that we have to answer. How does operating system know that which of these processes is actually a server, right? Do you understand the question first of all? Right. Now, there is a concept of ports. There is a concept of, okay, I'll repeat the question again. A user will make a request to welcome.html from their browser. Okay, user makes a request to this. The request goes to DNS. Fine. DNS will say this domain, server for this domain name is on this IP address. The request will come to this IP address. Now, this IP address is for the whole machine. It is not for some process, right? So out of all these five processes, which of these is the server? How will operating system will know that, hey, I'm getting a request to something like this. I'm getting a request to something like this. Out of all these five processes, which one will be able to respond to this request? Okay. Now the answer to this question is how operating systems are engineered is they say that okay, we will actually have all these ports on any operating system. We will have all these ports, right? There are around 65 or 66,000 ports on every machine. Now we can any process can start consuming these ports. Ports are nothing. You have sockets, right? You have sockets in your home where you plug your charger, somewhere you plug your geyser, somewhere you plug your fridge, right? All of these are electricity ports, right? And electricity is flowing in all these ports. Similarly, operating system has these ports. So what node, when we build the server, we will build the server in such a way that we will say, hey, we are going to use port number 3000. And this is very popular among everybody who knows React. So whenever we make a request to localhost 3000, the request is resolved from the React server, right? Similarly, our Node.js server is going to say, okay, I'm going to make use of port number 3000, right? So any request coming to port number 3000 will actually be uh, coming to Node.js server. So now, if instead we make a request to, let's say, port number 3000, right? Instead of saying just the IP address, instead we say port number, then we will know that operating system will easily identify that, hey, port Node.js server, this process is using port number 3000. Okay. So it will send the request uh, from uh, the whole operating system. The request will go to specifically that process which is running that server. Okay. Is this clear? Is this clear or not? There was a question that how will we identify which process uh, will resolve the request? The answer to that is Node.js server will start using a port number, and any request coming to that port number, operating system will simply redirect the request to that process, that Node.js process. Okay. If you don't understand this clearly right now, don't worry too much about this, because I'm going to anyway code this. Okay. I'm going to code this, and all of you have already seen HTTP localhost, right? HTTP localhost 3000. Everybody has used this, right? So this 3000 is the port number of the operating system where the your React server process is running, right? Are you able to follow or not? Okay, cool. Now this is the thing about operating system, and I'm just going to start building a simple HTTP server in Node.js. Okay, simple. This is HTTP server using core module. Localhost under the hood is a unique IP address. Yes, for every machine, uh, localhost nothing is nothing but the, if we open a new tab in Google Chrome, and if we type localhost 3000, operating system will not send the request to some external machine in or internet. It will just send the request to our operating system, this process, where any of the process which is consuming port number 3000. Okay, clear? Fine. Now let's start building the basic HTTP server which starts listening to request on some port number. Okay, so I'm just going to say server.js. Okay, now we are going to use the library and Node.js dev API docs, going to version number 14, let's say. Okay, 14 is still new. Okay, then fine, 12. Okay, so this is the core module that we are going to use, and this is HTTP. Now, there are a lot of things about this. There is HTTP agent class, there is HTTP client request class, and this is request has request.path, request.host. All of these we are going to start using. There is HTTP server class, so we are going to make use of that. Okay, so if you need help with any of the functions in this core module, you go to this URL. Okay, you go to this HTTP module and you can start searching. Okay, so if you need help with uh, let's say request.host, so this is that. Okay, it is going to be a string, and request.protocol is going to be a string, all of this. Okay, so let's start with importing this module. Okay, the first thing that we do is we create a server, http dot create server, like this. Now this takes a function. Okay, this is going to be a function, and it's called request listener. I'm going to define that in a minute. For now, it accepts two arguments, request and response. And for now, I'm just going to keep it like this. And once we have created a server, we say server dot listen. Okay, and then we give the port number. Just like we discussed, we have to start consuming some port number where we can send the request. Okay, so I'm just going to say port number 3000, right? So once we do this, we can say uh, server listening or listening for requests on http colon slash slash localhost 3000. Okay, right. So once we have done that, go to http basics. Now I'm going to start this server. I'm going to run this file, and this will start listening. Okay, and what is going to happen? Do you think the program will start, and once it reaches this line, is it going to end or not end? Is it going to get terminated or not terminate? What do you think is going to happen? Okay, so you see, if I run this file, the file is not going to the program is not going to close itself now. Why? Because of this special uh, server that we have started. So now this is a never ending program. It will not end unless it crashes or it runs into some error, some type of error. Okay, it will not end. It will just keep running all the time if you don't close it yourself, or if it does not run into any issue. Okay, so the server are supposed to be running 24/7, and they never end. Okay, these programs will never end. This process is a never ending process. Server has to be up all the time. Fine, so since the server is up, let's make a request. So I'm going to open a new tab, and I'm going to specifically go to network tab, and I'm going to copy this, and I'm going to paste it here. Okay, I'm going to paste it here. So once I do this, you will see that there is no activity in this terminal, and this is still loading. Okay, the status is pending and it is still loading. Now this will keep on loading for a while. After that, it will terminate. The request will terminate. Now, why is this happening? It is happening because we are not dealing with the request at all. We are ignoring the request. That's why this is happening. Okay. Now to create a basic HTTP server, and see if this is loading, if I close this will stop loading. It will say, you will see, it says uh, error empty response. Okay, the server terminated. If I send a request now, if I reload this, you will see the request will go, and since the server is not running, there is nowhere no process is listening for request on this port number, so the request ends immediately. But if I run this and reload this, you see this will keep on loading. Okay, now we have to deal with this, and just to make sure that actually we are getting the request or not getting the request, I'm just going to say request received. Okay, and since I have changed this file, I have to restart the server. It will not automatically restart. Currently it is running the old file only. Okay, it is not reading the new it is not running the newest code, latest code. Okay, so see, just as I restarted the server, we get this. Okay, I will close this and I will send another request. So I send another request and we get request received. I will close this, I will send another request and we get another. Okay, so yeah, so now we have made sure that we are actually getting the request, right? So see, every time I reload, we get this log. Okay, now how do we send the response? We are not anyway sending the response. So how do we send the response? Okay, uh, so to send the response, we just say response dot write. This is a function where we write the response. Okay, then this takes some chunk. Okay, we talked about chunks, so we can write multiple chunks, and for each chunk we can control the size of it. I can have a complete HTML as chunk, or I can break the HTML into multiple chunks. So I'm just going to say first chunk. Okay, then I'm going to say second chunk, then I'm going to say third chunk. Fine, after that just uh, I'm going to restart the server. Fine, let's see what happens if I make a request now. So just keep observing for now. I will explain everything. So you will see that it is still pending and we are not getting any data. We are not getting any data. Why are we not getting any data? It is because we have to do a special thing saying response dot end. Once we end the response, then the transmission starts happening. Okay. So I will restart the server and I will run the updated code now. Okay, so restarted the server, I will reload, and you will see that I have received the response this time. First chunk, second chunk, and third chunk. There is no space, or we can add new line character. Okay, this time I'm going to run this server. Actually, I have to change the code and I have to restart. So just to do that, I'm going to run this server with a special type of script called nodemon. And instead of running node, I'm going to run nodemon. And nodemon is an npm package. You could, sorry, you can install npm. No, you can install nodemon by saying npm I global slash node slash g for global space nodemon, the name of the package. Now, with this, you can start using nodemon as well. This is nothing but running node.js. If any file changes, it will restart the server. Okay. it will restart the file. Okay, so yeah, now it is running node server.js, but if I change something, it will restart. Okay, if I change this, it will restart. Okay, once I save this, it will restart. So once I reload, now we get first chunk, second chunk, and third chunk. Okay, is this part clear? Any questions so far? You will see we are getting 200 status code. Even though we have not set the status code, by default, we are getting 200 status code. Okay, is this clear or not clear? Any questions here? Where are chunks shown? Chunks are not shown anywhere. We get the complete response, right? This is the response, and we get this data here. Okay, unable to understand the flow of the code. Okay, I will walk you through the code, and you will see. First of all, we have just imported the package, HTTP package. We create a server. Now, when we create a server, we can pass a callback function, and this callback function will control how the request will be processed. Okay, this is nothing but we will get for each request, this code will be executed. Okay, for every request we get on this server, this request this callback function will be executed. Okay, now we get the server object, and we can start listening to this server on this port number. Okay, once we start listening, we can make the call. If we don't start listening, then that means there is nowhere we can make the request. Is this clear? This is just 17 lines. So not even 17, just a few lines. Okay, now once we get a request, we can start writing response. This is where we handle the request. We say this is a function, request.write function, and if you want help with this function, then I you can read here. You can read send a chunk of the body, and you can read more about this. Okay, okay, is this clear? But that does not complete the request flow. We have to end the response. We have to end the response, then only the response will be transmitted. Is this clear? What is response.write? Response.write is a function. This response object is coming in the callback function. Dot write is a function. You can read more about it here. Response.write. So this is where we actually say that for this request, this is the response the server should send. Okay. Yeah, yeah. Aman, you can unmute yourself and ask the doubt if you want.
Yes, sir. Sir, I was asking कि लास्ट यूनिट में वी यूज्ड टू डू npm run start and फिर वो लोकल होस्ट 3000 पे वो पेज खुलता था अपन ने
Uh-huh.
जो प्रोजेक्ट बनाया था. तो हाउ इज इट डिफरेंट फ्रॉम ये जो अभी लोकल होस्ट सर्वर पे सुन रहा है. जो लोकल होस्ट पे हमने खोला है तो वो चंक्स दिख गए हमें जो भी हमने राइट किया था.
ये
हाँ, यहाँ
रिस्पॉन्स
पे.
देखिए हमें, है ना?
हाँ, राइट. तो ये दोनों लोकल होस्ट डिफरेंट है क्या? मतलब वहां पे तो हम लोग सर्वर पे कुछ काम नहीं कर रहे थे, वो तो हम लोग सिर्फ फ्रंट एंड कर रहे थे.
हाँ हाँ. So for 1 second. When we were working on the React app, right? There was a lot of things that were happening in the background for us. Remember, why you had to install Node.js before you could work on front end, right?
यस,
Do you remember you had to install Node.js?
यस, यस.
Or React gives us the capability of fast reload, right?
Yes.
Okay, so why was all of that? Basically, what is happening? Whatever code you're doing in React, right? It is not a server. It is just front end. It is just JavaScript files. Okay. Now, whenever browser makes a request, front end cannot load itself into the browser. There has to be a server which sends the JavaScript files. So background में क्या हो रहा था जो हमें नहीं पता क्या हो रहा था, रिएक्ट क्रिएट रिएक्ट ऐप से बनाया ना हमने वो.
Yes.
सो क्रिएट रिएक्ट ऐप प्रोजेक्ट जो है that has a very basic server which is serving your JavaScript files to the browser, and you don't even know about this. Okay.
Okay.
It is just like, okay, I'm going to show you what is happening. I'm going to show you. So you have your app.js, some component. Okay, some component is there. और रिएक्ट क्या करता है, रिएक्ट बिल्ड भी करता है उसको. ब्राउजर डज नॉट अंडरस्टैंड रिएक्ट, ब्राउजर ओनली अंडरस्टैंड जावास्क्रिप्ट. ब्राउजर को JSX का कुछ नहीं पता होता. ओके, तो रिएक्ट क्या करता है, तुम्हारे सारे JSX फाइल्स को इट कंपाइल्स इट इनटू प्योर नेटिव जावास्क्रिप्ट. ओके, then a very lightweight server is running on top of all of this, and that is sending the compiled JavaScript to the browser. Okay, but you did not know about any of that. Basically nobody told you all of this, but there is a very basic HTTP server running on localhost 3000. Okay, which is serving the JavaScript files which are compiled from your React code. Does that make sense?
Yes, yes, sir.
Okay.
Got it.
So suppose your JavaScript is this console.log. This is your JavaScript. Suppose this is your compiled JavaScript. Okay. Now, if I have to send this JavaScript to the browser, what you can do is you can, this is going to complicate things a little bit, but I'm going to give you a very simple idea that you say fs.read file synchronously. Okay. Then you say slash app.js. For encoding, you use UTF-8. This is app.js file. And now you write that as the response. Okay. So this time, if I send the request, I will get JavaScript in the browser. Okay. Does this make sense?
Yes.
I can make this index.html as well. That will actually make more sense. So this is my simple script tag. Here I have my okay, document dot body dot style dot background color is red. Okay, this time I'm going to read index dot html and see this. Okay,
Okay, okay, okay. Yes, yes, yes. Got
this
it.
is how React was compiling your JSX into pure JavaScript, sending that to the browser with the help of a very lightweight server. Okay.
Yes. And whatever we send to the browser, if it is JavaScript, वो उसको render कर देगा.
हाँ, ये हो रहा है रेंडर, बैकग्राउंड कलर चेंज हो रहा है एंड
Yes, yes. Got it. Got
log
it.
is getting printed. Okay,
Yes.
and all of this was coming from a very minimal index.html जो होता है शुरुआत में. ठीक है. Okay, yeah, so this is a very lightweight server in with Node.js. and you can understand what response.write function is doing. Okay. Any questions? Anybody has any other questions? This was a very good question, by the way. Coming from React, uh, you may get confused by why we are doing things so differently, because we don't have UI. All we are doing is just writing the code, executing that code in the terminal, and how do we even check how things are working? What should be our expectation, right? Fine. Uh, so I hope this everybody is able to understand this. Right now we have created a very simple basic server which only responds no matter what request I send. I'm going to send a request saying welcome dot html. I'm still going to get the same response. Okay, because for every request we are only dealing in the same way. We are not dealing differently for different type of request. Why are there three dots? Don't worry about this. Worry about what I'm discussing right now. Okay. So I mean, it's good to be curious. This is I'm going to tell you so that it will help you only, right? uh, what happens is many times students become very curious, and they start asking questions from here and there. But while it is a good thing, while it is a good thing to notice all of this, they lose focus on currently what we are teaching presently, right? What we are teaching in the present, they lose focus. And once they realize that, oh, I have not been paying attention for the last 5 minutes, they just give up. So all of the questions that you have, they should be there, and you should ask these questions. But please restrict all the questions. First of all, make sure what is being delivered in the lecture, you understand that. We have defined a curriculum for you. Whatever you need to know, that will be delivered in the lecture. If we think that these three dots are worth explaining during the lecture, we have already taken that into the lecture curriculum. Okay. So focus on the major things. These questions, these are very small questions. You can get these questions, answer to these questions from anywhere, from your mentors, from doubt sessions. You can get these questions answered from anywhere else. Lecture is the most important part where you get to interact with the instructors and make sure what is being delivered in the during the lecture, you understand this. This is something related to VS Code, saying that require is a common JS, it is a file is a common JS module. We can convert this to ES type of syntax, which is import. Okay. If I do this quick fix, convert this. So it is just changing the statement from require to import. Okay. That is it. I mean, I don't mean to uh, I am not saying that you should not ask questions in during the lecture, but make sure you understand what is being delivered. If you have understood, then that's well and good. You can ask any question if you want. Okay. This is why I am saying this, all of this, because I see a lot of students struggling and not knowing how to utilize the lecture with the best capacity, right? With the most efficiency. Don't take this in any wrong manner. Please ask questions and I'll be happy to answer if those questions are related or contributing to solving some doubts that other students may have. Okay. Sorry for giving this lecture, or this is just a pointer. Okay. I hope that makes sense. First of all, tell me, does this make sense or not? Okay. How many folks do understand everything that was taught during this lecture? Today's lecture, how many of you folks understood most of it, if not everything? Okay. What is the role of what is the role of server? So what is the role of server? Server's role is to listen for requests and then send the response for each request, right? What is HTTP? How does HTTP work? What is a three-way handshake? All these things. These are what you should have a good grasp on from this lecture. All these topics. Okay, great. Now, how to create a very basic HTTP server in Node.js? This is how. Okay, it starts listening to request on port number 3000. Now, why is port coming in this picture? Why all of a sudden? Why are we talking about port number 3000? Because uh because of this explanation that I gave. Okay, so everything should be everything is connected, and you should have a clear picture of everything that this server is doing. Okay, it is a server which is never ending process. If we kill it, then only it will end, and it is listening for HTTP request. If we make, let's say, FTP request to this server, it will not respond. It is only listening for HTTP server. This callback function is how we are dealing with every request. We are dealing with every request, no matter what is the endpoint, no matter what is the request uh, method, we are dealing in the same way. Okay. There is a question. What is encoding? UTF-8. Encoding UTF-8 is every file every file has an encoding. Since this is a text file, this is following the encoding of UTF-8. Okay. So while we are opening this file and reading the contents of this file, we are reading it. We have to read it as a text file. That's why we have to define this. If we don't read this, okay, if we don't pass this option, so it is going to be a buffer type of this file now is going to be of type buffer instead of going to be of type string. Okay, but if we want it to be a string, then we have to say UTF-8. Okay, now you can see the file type, this the type of this variable becomes string. Okay. Okay, now if there are no questions up till this point, we are done with today's lecture. This is how we create basic server. This is a very simple server. uh, you could modify this by checking for different type of request URL and request method. If you use these properties, and if you can use switch case and if else conditions to have different type of response for different type of request. So if I make, let's say, if I make request to profile dot image dot png, then you will see that request received, this is the URL, and this is the method. So you can use combination of this with if else condition and send a different message, sorry, different response for different type of request. Okay, you don't listen for each URL, you just listen for port number. If you want to serve uh, different response for, let's say, request dot, if request dot URL is, say, welcome page, right? Welcome dot HTML. If this is the URL, and request dot method is get, then I want to send different type of response. Otherwise, I'm going to send a different type of response. Okay. Mm, This is the welcome page, for example. Okay. So see, if I make a request to this URL, I get something else. I get this text. If I make request to this, then I get something else. So this is how you deal with different types of requests. You have not explained difference between HTTP and HTTPS. Okay. And why browser throws error when connected to HTTP. Okay. So HTTPS is nothing but a secure version of HTTP, right? Coming to the diagram, whatever HTTP is doing, it has been found that the transmission of data, right? Transmission of data back and forth is not encrypted. So anybody who is also using the same network can actually read this transmission. And if this is not encrypted and we are sending password, email, password, all of this in request body, it can be stolen. Okay. So everybody has identified this as a problem, and browsers, all the browsers recommend that you do not use HTTP in your website. Instead, you should use HTTPS, where the data is transmitted after being encrypted. Okay. So even if somebody is on the same network snooping on your request data, they will not be able to decrypt emails and passwords. And that is the only difference between HTTP and HTTPS. Browsers throws the error. Browser will throw the error if you're using HTTP, because it thinks that it is not secure to use HTTP. Then there is a question how browser decrypt the data. That is beyond the scope of this lecture. If you want to know more about this, you can refer to some YouTube videos about this. But yeah, this was just a summary of the difference. Fine. Okay. So I have to end the lecture now. But if you have any questions, please go through the video and note down your questions. I'll be happy to answer all those questions in tomorrow's class. Okay.